Hi, Mobile Mighty God. I'm Asa Sankosha, and today I want to talk about chemical reaction engineering module in computer multiphysics simulation software. Now I want to go to the flux section. This node can be used to specify a species flux across a boundary of a porous structures, apply the points in two dimensions and allow edges in three dimensions. The flux of a species C is defined as N dFR dE delta C is equal to dFR N0. Well, N0 is an arbitrary user-specified flux expression. For example, N0 can be represent a flux due to chemical reactions or phase change. A positive N0 implies that the concentration inside the fracture increases. Now I want to go through the involved flux. The available options are general involved flux and external convection. If the latter is chosen, define the mass transfer coefficients and the bulk concentrations. Specify the flux of each species individually. To use another boundary condition for a specific species, make sure that the checkbox for the mass fraction of the species is clear. Now I want to go through the inflow. Use this node Use this node to specify species concentrations at a fracture inlet. The conditions apply the point in two dimensions and a log edge in three dimensions. If you want to specify the concentration of a subset of partaking species, this can be done by using the concentration node instead. Now I want to go through the concentration. For the concentration of each species 0C, based on the effect it is molar per cubic meter, it's a value or expression. Now I want to go through the boundary condition type. This section in setting is only available for some products. Search for info on the page computer.com/products/specifications. For more details on availability, the option concentration constraint constrains the concentration values on the boundary by the use of point-wise constraints. The other option, flux chambers, can be more stable and fast to solve when high reaction rates are anticipated in the vicinity of the inlet. Oscillation on the solutions can also be avoided in such cases. The latter condition uses the flux boundary condition based on the velocity across the boundary and the concentration values. See further details in the theory section. Now I want to go to the constraint settings. To display this section, click the show button and select the advanced physics options. You can find details about the different constraint settings in the section constraint reaction terms in Consumer Physics Reference Manual. Now I want to go through the further reading. See the theory chapter in the section, then words inflow boundary conditions. Now I want to go to the no flux section. This node can be used to specify that the species flux across the boundary of a porous fracture is zero. The conditions apply in point in two dimensions and along edges in two dimensions. Now I want to go to the outflow. See this condition and fracture outlets where species are transported out of the model domain by fluid motion. The condition is applied in points in two dimensions and along edges in three dimensions. It is assumed that convection is the dominating transport mechanism across outflow boundaries, and therefore that diffusive transport can be ignored. That is, n is equal multiply minus d delta c is equal to 0. Now I want to go through the reactions. Use the reaction node to account for the consumption or production of a species through chemical reactions in the future. Define the rate expressions are required. Now I want to go through the boundary selection. From the selection list, choose the boundary on which to define rate expression or expressions that govern the source term in the transport equation. Several reaction nodes can be used to account for different reactions in different parts of the fracture. Now I want to go through the reaction rates. Add a rate expression Ri for species I into a value expression in the field. Note that if you have the chemistry interface available, include the chemical reaction engineering module. The reaction rate expressions can be automatically generated and picked up from the list. Now I want to go through the reaction and reacting volume. When specifying reaction rates of a species in a fracture, the specified reaction rate may have the basis of the pore volume of the fracture or the total volume. For total volume, the reaction expressions are specified per unit volume of the fracture. The reaction expressions will be multiplied by the fracture thickness DFR. For pore volume, the reaction expression is molar per cubic meter second are specified per unit volume of the total pore space in the fracture. The reaction expression will be multiplied by the fracture thickness dA fracture and the fracture porosity epsilon p. Now I want to go through the species source for the next session. We will go through the species source. Thank you so much for watching my tutorial video until the end. Today is 12th of May 2026. Time is 12:37 a.m.